All right, we are on section 2.5, and 2.5 is going to deal with studying the gas laws. Now, we've been focused on gases for the last couple sections, and this continues. So, review here, what are the three ways in which we can study a gas? They are volume, temperature, and pressure. And what we can do is we can combine those three things into a handful of equations that help us solve what the properties of a gas. And the first one that we can do is Charles' law. Now don't worry about writing down this law states that the volume of gas is directly related to the proportional temp. You know what Charles' law is, guys? Charles' law is this. Charles' law is this equation. And to clarify for that for you, might be V1 over T1 equals V2 over T2. Now, also, whenever we are using temperature with gases, we have to use a unit of temperature called Kelvin. Now, you guys are familiar with Fahrenheit. You know a little bit about Celsius, but you probably have never used Kelvin before. And this is the reason we have to use Kelvin when we're talking temperatures. We don't like doing calculations with negative numbers in science. So if you think about this, does Fahrenheit have negative temperatures? Absolutely. Does Celsius have negative temperatures? Yes, it does. Does Kelvin? The answer to that is no. And why? The coldest possible temperature on the Kelvin scale is 0. Let me say that one more time. The coldest possible temperature on the Kelvin scale is 0. So 0 is the coldest. There are no negative values in the Kelvin system, so we use all our temperatures are in Kelvin. So our first law is V1 over T1 is equal to V2 over T2. V stands for volume, T stands for temperature. And the 1 stands for the initial sample, and the 2 stands for what happens if the sample changes. And that was what I was just saying. Temperature must be in Kelvin. Second gas law that we can study is Boyles Law. And again, you don't have to get caught up in writing down all the words. This law states that the volume of a gas is inversely proportional to its pressure. Don't worry about that. It's this. This time we're multiplying instead of dividing. Boyles Law is P1 times V1 equals P2 times V2. P stands for pressure. V stands for volume. 1 stands for the original sample. 2 stands for what happens if the sample changes. So there's a little graph showing Boyles Law. Don't worry about that. So we have Charles' Law. We have Boyles Law. We also have the combined gas law. This law states blah, 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 blah. You don't have to worry about knowing what the combined gas law states. Just know that there's the equation for it. P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. Now, P stands for pressure, V stands for volume, T stands for temperature. 1 stands for the initial, the starting point, and all the 2's stand for what happens if it changes. Now, one way that I like to write this equation, instead of the division, I like to cross multiply. And remember, when we cross multiply, we're going to take this times this is equal to this times this. And what we can do is we can rewrite this equation as P1 times V1 times T2 is equal to P2 times V2 times T1. Now, a couple things with these equations. You do not have to memorize them. They will be given to you. So we're just kind of going through the equations, but they will be given to you. So you have Charles' law, Boyles' law, the combined gas law. All three of these equations will be given to you. Now, if we look at the combined gas law, all right, that's what we just had. I don't know why my slide repeated. Sorry about that. So Let's do an example using one of these three laws. So we're going to have some gas law math practice here. A sample of neon gas occupies a volume of 75 liters at 298 degrees Kelvin. Remember, Kelvin is temperature. What volume will the gas occupy at 323 degrees Kelvin? So kind of keep that in mind. A sample of neon gas occupies a volume of 75 liters at 298 degrees Kelvin. What volume will the gas occupy at 323 degrees Kelvin? A couple things that's important to do and really helps you out. Highlight everything that you have. So we have 75 liters, 298 K. It's asking for what will the volume be. So we are solving for volume, and it says occupies at 323 degrees Kelvin. Now, when we write everything down, we need to determine what's the initial sample. Well, it says in the first sentence, a sample of neon gas occupies a volume of 75 liters at 298 degrees Kelvin. We can assume that that is our that's our initial sample. So 75 liters is volume, so I'm going to go V1 is equal to 75. I'm going to go T1 is equal to 298. Then it asks us what changes. What changes? Well, it's asking us to solve for the volume, so we are going to have to solve for volume 2, which we don't know, so we'll put volume 2 equals x, so as we don't know, so we're going to solve for x. And it occupies the gas at 220 or 323 degrees Kelvin, so T2 equals 323. Now you have a couple choices to make. You have three equations that you talked about. We have the three equations that you have are P1 V1 equals P2 times T or V2, excuse me, V2. You have V1 over T1 is equal to V2 over T2. And you have the combined gas law, which is P1 times V1 over T1, which is equal to P2 times V2 over T2. You have three equations to choose from. Which equation are you going to use? Well, can you use the P1 V1 equals P2 times V2? No, because we don't have pressure. Right. Can we use the bottom equation, P1 times V1 over T1 is equal to P2 times V2 over T2? No, because we don't have pressure. Can we use this middle equation? V1 over T1 is equal to V2 over T2. Absolutely. So we can go ahead and use this and solve. So let's go ahead and use this equation. Let's plug everything in. Our V1 is 75 over our T1, which is 298. That's equal to V2, which is x, over our T2, which is 323. We're going to cross multiply. When we cross multiply, we are left with 75 times 323 is equal to 298 times x. So it'll be 298 times x. When you take 75 times 323, you end up getting 24,225 is equal to 298x. Last step is to do some algebra. We're going to divide both sides by 298. 298 cancels, and x is equal to 24,225 divided by 298, which when you do that, you end up getting 81. 81, and what is our unit for volume? In this example, it was liters. So x equals 81 liters. We will continue to work with gas law equations and how to work with them, and the combined gas laws and Charles gas law and Boyles gas law as we continue the section. So we'll do some work with these math problems tomorrow.